last example for this chapter is looking at significant difference or significantly more or significantly less for population proportion. So very similar to what we did in chapter 8. We use z-scores, we calculate z using proportions, and then we're just going to see if there's a difference. So what we're going to do is say that there's a proportion out there. It could be the known approval rating for the president. And do we take a sample? Is it significantly different than that? So let's get into a good example here to kind of take a look and do this. Again, I'm breezing through this part. It's all identical. We're still going to look at the p-value approach versus the critical approach. Everything's the same except we're comparing a sample proportion. That's the sample proportion to the population proportion. So go back and watch the first video that I did for chapter 8 if you need a little bit of a refresher on null and alternate hypothesis. So here's an example. We want to know basically if 50% of the accidents are caused by drunk driving. And since that's the estimate out there, we want to know if this is actually true. And so there are 500 people that were killed and 250 that were injured. And again, the National Safety Council claimed that 50% of the accidents would be caused by drunk driving. So we took a sample of 120 accidents, and we had to determine what, go through that data, look at it, and we determined that 67 of those were caused by drunk driving. Now, think about this. We want to prove this claim correct. All they're saying that it's equal to. So we want to see if it's either equal to or significantly different. Now, we of course know that 67 divided by 120 is not 50%, but is it significantly different than 50%? That's what we want to know. So taking that information, let's look at it up here. We've already got the information up that we have. 55.83% would be our sample proportion. Our population proportion, which is represented as p sub 0, is 50%. We're going to say our significance level, again, is 0.05, and this is what that would look like. You then would have 50% here and two-tail test. In each of these tails then is 0.025 here, 0.025 here. And let me ask you this, what's the z-score that corresponds to 0.025? Hopefully remember that from chapter 8, that's 1.96 and negative 1.96. So if we're in this tail, we're significantly different. If we're in this tail, we're significantly different. Obviously, 67 divided by 120 is greater than 0.5, but is it out here or is it somewhere close to the 0.5? That's what we want to know. So looking at our information here, we calculate our computed value of, actually that would be our standard error, and we come up with a z-score of 1.28. So what that means, let's take a look at that on our board up here. We're going to take p minus p sub 0, and then we divide that by p sub 0, 1 minus p sub 0 over n, and then we take the square root of that, and that gets us z. And so that's what you see there, the 0.5 times the 1.1 minus 0.5 divided by 120. And so that's where you get the 1.28. Now let me show you where those values come. So 0.5583 minus 0.5 over square root 0.5, 1 minus 0.5 over 120, take the square root of that, and again, that gets you 1.28. So that's the calculated value of z. Where does that fall on our bell curve? That falls about right here. And we can already see that that tells us that that 0.5583 is not that far away from the mean. based on the data that we have. What is the p-value that goes along with that? Let's take a look. We then take 1.28 and we find out 0.8997 is what you would have on the one side. Now, so let's take a look at that on the board. I'm going to draw a completely separate bell curve to make the point of this. So at 1.28, this area is going to be 0.1003, and then the rest of this area is the 8997. So all that means is from here over is 8997, and then that area is 0.1003. That's one tail that I'm comparing to two tails. So to make this be the same as this, I have to multiply it by 2, and that's why my p-value is actually double when it's a two-tail test. So that p-value in this case is definitely larger than 0.05, which again is these two values together. Therefore, it's not significantly different. And the 1.28 is not greater than 1.96, and it's not less than a negative 1.96. Therefore, it's not significantly different than 0.5.